In this presentation we are going to look at even and odd functions. It's an important matter to know if a function is even or odd in a lot of analyses. For example, if you're doing Fourier transform analysis or something like that. So even function, a function f of x is even if we could say the following, that f of x is equal to the f of minus x. So let's just have a quick example here. This one would be, let's say f of x is x squared. Okay. Now, let's just say for argument's sake that we put in f of 1, that's equal to 1 squared, and that's equal to 1. And let's try it out for the minus input. That would be f of minus 1. That would be minus 1 squared. And that would be 1. Okay. If you're using this trial solution approach, just as a matter of just try out two different values, or x and minus x, it might be just handy to do a second test, just in case you accidentally get a sort of pick the one number where they just happen to be equal by accident. It's not true by design. So you might go f of 2 there equals 2 squared equals 4, and f of minus 2 equals minus 2 squared equals 4 as well. Do it a second time if you're going to try the trial solution. Some well-known examples of even functions: cosine of x, the absolute value of x, and anything to the power of an even number. So we just used x squared up there. So x squared, x to the power of 4, x to the power of 6, and so on. An odd function is a function is said to be odd if we could say the following: f of x equal to minus f of minus x. So let's have an example of that. Let's just say, for argument's sake, let's just try this out. So f of 1, f of x, let's say, is x cubed. Okay. F of 2 equals 8. That's 2 cubed. Now, f of minus 2 equals minus 2 cubed, and that's equal to minus 2 times minus 2 times minus 2. That's equal to minus 8. Okay, and there we could say that f of x equal to minus f of minus x. So in that case, this would be an example of an odd function. Very well known example there is sine of x, and anything to the power of that should be an odd number, x to the power of 3, x to the power of 5, and so on. Okay. Now, just as a remark, some functions are neither odd nor even. Actually, I removed that example because I think it might be actually odd after all. But some functions are neither odd nor even. So it just like, it's not a sort of dichotomy. It has to be one or the other. They could be neither odd nor even. They could just be functions. You can have combinations of functions. This is quite important to remember. You can try it out with some trial solutions if you want as well. But a couple of rules of thumb. Functions that are products of two even functions are also even. For example, let's say x to the power of 2 times x to the power of 4. Well, that would be x to the power of 6, which is an even function. Functions that are products of two odd functions are also even. This is a bit of a strange one. People wouldn't sort of cop this. And it's actually in this sort of situation where, like, trying out a few values and see how that works also would help. So, for example, we've x times x cubed, we get x to the power of 4. Okay? So if you anything to the power of so I said, like, you give another example there, x cubed times sine x. That should be an even function. Functions that are the product of an even function and an odd function are odd functions. Okay. Okay. So a quick example here. This is a multiple choice question. We're given two functions and we're asked to make a decision on the answer. Just as a quick remark, this has the values are for -1 to 1. So the range is the range of these functions are specified. So straight away, g of x, that's x to the power of 1. That's an odd function automatically. Let's look at some of our examples here. We can so both are even. Well, we can automatically discount that. F is odd and G is even. We can discount that. Some of the other ones are potential. F is even and G is odd. That might be the case. Both are odd. At least one is neither odd nor even. Well, that could be the case. If this is a neither case, then it's answer G. Okay, and it's actually what I might sort of specify there or state there is just it's one function minus another function, so it's not something we've come across. Let's try it out. F of, let's say, 0.5, and that is, again, for the sake of brevity, I'm only going to try one value. I wouldn't recommend that in general, but I'm only just for the sake of keeping the video short. I'm only going to try out one value, and the answer will be right. But I invite you to just sort of double check at a different value. For example, f of 0.25. So f of 2.5, that's 0.5 minus 0.5 squared over 2. That's equal to, I'll just give the answer there quickly. It's 0.375. That's just a bit of calculator work. F of minus 0.5 equals minus 0.5 minus 1.25 or 0.125. And that is equal to minus 0.625. Okay. Now, f, it's not odd. In fact, it's not even, because they don't have they don't even have the same numbers. So it's not odd. It's not even. So it's a neither case. Okay, it's not. They don't give the same number. They don't give the negations of each other. They just give totally different numbers that are not related in any way. So this is a neither case. So we have a neither. F of x is neither. We know that now. No question mark. And g of x is odd. So actually, the answer to this one is. I'll just scroll down a bit so it's just in shot. A bit better. The answer is at least one is even. Neither even nor odd. F of x is actually neither. Alright, that is the end of this presentation. Let's wrap that. It's my 8 minutes 51.